Okay, the last section in this chapter, this I guess not the module, but in this theme of rational expressions, deals with things called variations and applications of those variations. We're going to look specifically at two types: direct and inverse variations, and here they are here. So direct and inverse variations, and then we'll look at some applied problems, and there might be some other types of variations that we'll look at the end. All of these are like formulas, but all of the things we've done in this last little section with rational expressions or equations will help us solve these. To begin with, a direct variation can be identified from their graphs. They're linear functions. So direct variations, they are simply lines. So the other interesting thing that you get from a direct variation is that the quotient of any two numbers on the graph is always the same, or it's a constant. So here, how much money you have to pay when you go over your cell phone minutes, that's the red part, it's a direct variation. If you go over 10 minutes, you're going to have to multiply that by whatever the rate that they have is to tell you how much you're going to pay. But it's a direct variation. In any kind of variation, there's always a constant. And the formula that we have for direct variation is this here. And the constant is this number that appears in front of the x. So I have a direct variation between y and x. It's direct, and the constant of variation we call k. Knowing that this is a straight line, this looks very much like something like this without the plus b part on it. And so this direct variation, the k, turns out actually to be the slope of that particular line. So here's a quick question about direct variation. It says find the equation of variation and y varies directly as x when y is 8 and x is 20. And so what I do in this case here typically is what I'm always looking for is I always want to find the constant of variation. So typically questions are two-steppers. Find the constant, then use that to help you solve another question. This one I think I only need to find the constant, but typically that's what we do. We find the constant and then we use that in another application. So if this says it's directly, as soon as I see directly, I can immediately write y is equal to k times x. Then they say y is 8 when x is 20. And so here I have an equation that I can solve for k. It'll be 8 over 20. To simplify that, 4 will go into both of those, so it'll be 2 over 5. So the constant of variation is 2 over 5. So now I can rewrite the equation. Typically it's y equals k, k times x. But now that I know the constant, I can write it as y is equal to 2/5 x. So this would be the equation that describes the variation indicated by those two terms. Here's another application of that. Here it says in Canada, we produce more garbage per person than any other country. That's a little scary. If on average 50 people produce 4,000 kilograms of garbage in 1 month, how much garbage would a city like Lethbridge, where we have 70,000, produce in a month or in a year? Let's first figure out the month thing. Now, in here somewhere, they should have said something about variation. I don't see anything in there, but we should say something like the number of people varies directly with the amount of garbage that they produce. Okay, so let's plug some numbers in, find our constant of variation. So I have 50 people, 5,000 kilograms of garbage, or 4,000 kilograms of garbage. So let's plug those numbers in. 4,000 for y, k I don't know, x is 50. So divide both sides by 50. that would come out to be 80. So my constant of variation is 80. So I can rewrite my equation, y is equal to 80 times x. Now I'm ready for them to ask any other question. And here they say, how much garbage would a city like Lethbridge, population 70,000, produce in a month? I can do that. My population, or the number of people, is x, so I'll go y is equal to 80 times 70,000. So in 1 month, the city of Lethbridge would produce 56 with 5 zeros. There. So 5,600,000 kilograms of garbage. That's a whole lot of garbage. That's in 1 month. To do a year, of course, I'd just take and multiply that by 12. But that's a whole lot of garbage in 1 year. Example of direct variation. Here's our equation. Find the constant of variation. So now I've got an equation that describes that direct variation, and then use that to help me solve other questions that are related to it. Okay, let's look at inverse variation. An inverse variation arises when the product of coordinates points are a constant. In other words, if I have a point, if I multiply the two values together, they are a constant. If that happens, then what I come up with is a inverse variation. So here's a question that might be interesting for you. Assuming all people work at a constant rate, the relationship between the number of workers and the time it would take to rogue a field of canola would have an inverse relationship. In other words, the more workers that are roguing, the less time it would take, assuming that they all work at a constant rate. And here's a formula I can use for inverse variation. Notice it's similar to direct, except the x now is in the denominator and the constant remains up top there. Let's try a question. So here it is. If it takes 3 people 30 minutes to rogue a row of canola, how long would it take 18 people to do 1 row? Okay, let's first find our constant. So it takes 3 people 30 minutes to rogue 1 row of canola. So let's see here. I'm going to put my minutes. Let's put our minutes over here. Is equal to k over 3 people. So to solve for k, I multiply. 30 times 3 is 90. So my constant is 90. Let's rewrite our equation, including 90 in instead of k. So here's my equation of inverse variation. So now they say, how long will it take 18 people to do 1 row? Well, I put my people down for x, so I'm going to replace x with 18. So 90 divided by 18, I think, comes out to 5. So if it takes 3 people 30 minutes to rogue 1 row, how long would it take 18 people? It would only take them 5 minutes to rogue that 1 row. Okay, if you want, you can pause and try maybe some questions in your textbook. But here's a couple of other little similar kind of applications to variation. Here's one. The area of a circle varies directly as the square of the radius. Notice it's not a normal directly one because I'm squaring something. But here's the formula that would result. Area is equal to k times r squared. It turns out that the constant of variation is pi. And you've probably seen that formula before. Okay, like I've shown there. Another example of one. At a fixed temperature, the resistance of a wire varies directly as the length and inversely as the square of its diameter. Oh, that's sort of ugly. But if I write that, it varies directly, so I'll put that on top. There's a constant here, an L, divided by the square of its diameter. That's an interesting formula. If the resistance R is 0.1, let's write that in there, 0.1, when the diameter is 1 millimeter, so K I don't know, but the diameter is 1, I have to square that, and the length is 50, so L is 50. So I can use this information here to help me figure out what the K value is. So 1 squared is 1. 1 multiplied over here would still be 0.1 is equal to K times 50. Now if I divide both sides by 50, I get 0.1 divided by 50. That comes out to 2, I think. 0.002 is equal to my constant. Is that right? 100 divided by 50. Yeah, that's right. Okay, so my constant is 0.002. So I can rewrite my equation as R is equal to 0.002 L over D squared. Now I can answer the question that they ask later. Remember I said that's often what they do. Have you find the constant, then use that? Okay, so let's use it. R is equal to 0.002. Do they give me the length? When the length is 2,000, okay, multiplied by 2,000, divided by, and the diameter is 2. So this is 2 squared. So my resistance is equal to 0.002 times 2,000 divided by 4. Okay, so 4 goes into 2,500 times. 500 times 2 would be 1,000. I'm going to have to do this over here. 500 times 0.002. So 2 times 500 is 1,000, and I need 3 decimal places. So it comes out to, the resistance comes out to 1. Okay, so those are some types of variation questions that you'll see. Again, I reiterate that often the question has you find out what the constant is first, and then use that constant in helping solve the rest of the problem. Try some questions as usual in your textbook, and if you have questions from those, holler at your instructor.